The next topic we'll be dealing today in operating system is related to file allocation methods. In all the previous sessions, we have seen what is a file and what are the different attributes that are related to a file and how do you actually protect the data that is present in a file. Now we'll see how to actually store the data on of a file onto a disk, right? We have various file allocation methods. We have contiguous file allocation and we have non-contiguous file allocation. In contiguous file allocation, though you divide your file data into parts and all the blocks of these files are stored continuously onto your disk, where we actually store the data of the file onto the disk, right? And coming to non-contiguous file allocation, we have linked list allocation and indexed allocation. We'll see each one of them in detail. Coming to contiguous allocation here, we have a disk which is basically divided into blocks here. So you have this blocks 0, 1, 2, 3, 6, 7. These are all the blocks which are present on the disk. Now you want to store the data. So when you want to store the data here, you will be identifying the contiguous empty blocks and store the data accordingly. Now for example, if I go for mail, so mail is my file and I'll identify what are the location for continuous blocks that are available. So I'll start storing my mail data from 19 till 24. So all the file blocks related to mail is stored onto this the particular disk blocks. But how do you know which of the file is stored in which of the blocks? For that we maintain a directory or we call it as file metadata, which will give you the information related to a file. So in this particular directory we'll write the name of the file, what is the starting block number and the length. This is not the ending block number, it is just the length of it. Means that if I go for my file count, you start storing from 0th block and what is the length of it? 2 blocks. So 2 blocks are being stored. So 0 and 1 will contain the data related to count. Similarly, when you go for tr, the name of the file, your starting block is 14 and 14, how many blocks here? 14, 15, 16 will contain this data tr. So this directory will maintain the name of the file, what is the starting block number and the length of the blocks. So when you see this, it is very easy to implement and there is a minimum amount of seek time because you are directly getting the block number. You need not go for, if you are going for list which is at 28 starting block, you need not traverse. You can directly go to 28 and get the data. And the disk head movement is very minimum because you are placing onto the particular block instead of rotating it. And memory access is also faster and it supports sequential. Why you say it supports both the sequential as well as direct? When I go for direct, if you go for list here, what is the block here? 28. So you directly go to 28 and from 28, if you want to access the data of the list, you have to move one after the other. So that is sequential. And coming to the disadvantage here, when you are storing the data onto the file, you have to be very much sure how many blocks your file data is being divided into. So at the time of creation, the file size must be initialized. And since if I say my file something as txt file can requires 10 blocks at the starting, and while you are in the operation of performing an operations here, you may increase the length of the blocks here, but that is not possible. And because of this fixed allocation or continuous allocation, you may get a problem of internal or external fragmentation, which we have already covered when we are dealing with paging techniques. To overcome the problems of fragmentation here, we go for the next type of allocation, which is nothing but linked list allocation. As we know, this is nothing but your disk and this contains multiple blocks. And this is not, as we have seen earlier, it was contiguous allocation where you are storing the data continuously, whereas this linked list is related to non-contiguous file allocation where the blocks can be at different stages, they need not be adjacent to each other. So here when you are storing the directory structure here, file, you first store the name of the file and you store the starting block number and the ending block number, and you establish a pointer to your starting block number and you establish a pointer to your ending block number. If you can just see here, this is your starting block number 9, which is in turn pointing to one block, 16th block, 16 is pointing to 1, this is your block number. 1 is pointing to your 25, 10 here, 10 is pointing to 25. And when you see this block number after 25, you don't have any other block you finish storing your data, so it will be represented with -1. Whatever value you have here, it is nothing but the actual data which is used for representing it. So in the directory of your linked list, this contains the name of the file and a pointer to your starting block and pointer to your last block, and this particular last block will contain a value -1, indicating that you don't have any other data to be stored. And each of these blocks has a value corresponding here. It indicates that after 9, what is the next block where you have to move on to. So you will be moving on to 16. 16 is containing a value 1, so you'll move on to 1. 1 will contain a value 10, so it move on to 10. 10 will contain a value 25 and you move on to 25, and this indicates a pointer which indicates that it is the last place where you can stop searching for the data. The advantage of this particular linked list allocation is there is no external fragmentation required, and when you want to store the directory structure, you need to just store the starting address of the block, and the memory here need not be contiguous. It can be at any location. That's the reason we will not have any external fragmentation. And here it will not support your random access or direct access. Why? Because one after the other, depending on the pointer, you have to traverse through all the blocks in order to get the data of the file. And since you are dealing with pointers, as it implies, if there is a problem with any one of the pointer here, you will not be able to move on to the next block to get the data. And for storing these pointers, you require an extra space in the memory. So these are some advantages and disadvantages related to linked list allocation. Now, a variation of this linked list allocation, we call it as a FAT, which is nothing but file allocation table. As we told that for storing the pointers data, you require extra space. To overcome that particular problem, they have come up with a new technique where in the directory entry, you just write the name of the file and indicate the starting block number. So, and this starting block number will point to that particular block, and this block in turn contains the address of the next block. So you go on to that particular block, and this contains the address of the next block, and when you finish traversing, this is nothing but the end of the file. So instead of storing the starting block number and ending block number, you only maintain the starting block number and you can traverse to all the blocks of the file. The next allocation what we have here in this is indexed allocation. So when you go for seeing here indexed allocation here, out of all the blocks, this also comes under non-contiguous allocation where the blocks will not be allocated continuously to a file. They can be scattered around, and each of the block will be used for storing the part of the file data. Now, out of all the blocks which are available, you designate one of the block as the index block, and this particular index block will contain the address of all the blocks or block numbers where your original file content is present. So here 9, 16, 1, 10 and 25 indicates that the file content data is present in all of these blocks. And this -1 indicates since the block size here is for holding these many values, since you don't have any block numbers here updated, you are just representing that with a -1. So the directory structure will be maintained with the name of the file and just the number of your index block. And you have a pointer pointing to index block, and this index block will contain the address of remaining all other blocks. As you can see, this supports direct access because you can directly go to that particular file block number which is present here, and it overcomes the problem of external fragmentation. And this pointer overhead is the pointer problem which we have faced in your previous linked list allocation. The same exists in this also, but the problem here is, for example, if I am going for an index block 20, and here I'm able to use only two disk blocks 1 and 2. So even though my size of the file is very small and in the disk I'm only using two disks here, but you need to maintain the total block depending on the size of your block. If it is 1 KB or 200 KB, the total block will be only allocated for storing the indexes. So if the number of indexes here are very less, you are totally wasting the index block memory. So that is the main problem when you go for your indexed allocation. Now in indexed allocation here, we can go for using various techniques to overcome all these problem related to our pointers. We can go for using a mechanism known as linked scheme, multi-level index, and a combined scheme. So what we do in linked scheme is, in one of the block, you just write the address of your starting block, and this will be acting as a link to remaining all other blocks. So you go for establishing the links here. Or in multi-level index scheme, what you do is, you have two levels. On one particular level, you point to the actual, this will point as same as your pointer to pointer. This contains the address of your index block. So this just contains the address of the index block, and this is your actual index block. And from the index blocks, you get your data. So in order to reach the data, you need to move through two pointers. Whereas in linked scheme, when I go for linked scheme, this is just a pointer, and using this pointer, you can actually access your data. Or you can go for combined scheme. So when you go for your combined scheme here, we have three variations of combined scheme: direct blocks. So in the blocks itself, you actually store the data. So this will be just pointing to the data. So direct block will contain the data. So if you want to store the name of your name of a student in a file, you can directly write it as something as ABCD. So this is your actual data. Whereas in single direct block, in the block you will not store the data, but you store the address, and when you go to that particular address, you will be able to find your actual data. Coming to your double indirect here, as I told you about your multi-level index, it is a pointer to pointer which contains the address of this data, and this in turn will provide you the data. So two level of access is required for getting onto your original data. So these are the different techniques which can be used for allocating the data onto the blocks that are available onto the disk.